Have you ever taken a close look at your fingertips? Those swirling patterns of ridges aren't just for show, they're a unique part of who you are. From gripping objects to enhancing your sense of touch, fingerprints serve practical purposes we rarely think about. But here's the fascinating part. No two fingerprints are the same, even among billions of people. How is that possible? And what makes these tiny ridges so special? Let's start with the basics. Fingerprints, or friction ridges as they're scientifically known, have a practical purpose. They help us grip and interact with the world. A study published in the Journal of Experimental Biology by Dr. Roland Enos from the University of Manchester explored how these ridges improve friction between our skin and various surfaces. His research showed that the friction ridges increase our ability to hold objects, especially under wet conditions, preventing slippage. But fingerprints don't just help us grip, they also enhance our sense of touch. Neuroscientist Dr. Sleeman Bensmeyer from the University of Chicago conducted studies demonstrating how the ridges amplify vibrations as we touch different textures. The ridges allow tiny receptors beneath the skin to detect variations in surface patterns, making us more sensitive to texture than we would be with smooth skin. So how do these intricate patterns form, and why are they unique? Fingerprints begin developing as early as the 10th week of gestation, influenced by both genetics and environmental factors. A study published in Nature Communications by dermatologist Professor Anne Bocock highlighted how specific genes, such as ADAMTS9 and EDA, are linked to the development of dermal ridges. But genes are just part of the equation. Other research, like the 2011 study led by biologist Dr. Dennis Bramble, found that factors such as fetal movements, pressure from the uterine wall, and even amniotic fluid dynamics help shape the final pattern. The result is a unique blend of nature and randomness. While the general fingerprint patterns, loops, whorls, and arches, are largely inherited, the finer details are shaped by tiny, unpredictable influences. Even identical twins, who share nearly all their genetic material, have distinct fingerprints due to these small environmental variations during development. Humans have been aware of the uniqueness of fingerprints for a long time. In ancient Babylon and China, fingerprints were used as marks of identification, pressed into clay or wax. But it wasn't until the late 19th century that the scientific study of fingerprints took off, thanks to Sir Francis Galton. Galton, a cousin of Charles Darwin, was fascinated by the variability in human traits. In his 1892 book, Fingerprints, he quantified the likelihood of identical fingerprints occurring, calculating that the probability was less than 1 in 64 billion. This pioneering work laid the foundation for fingerprints becoming central to forensic identification. Today, fingerprints are more than just tools for detectives. We use them to unlock our phones, secure our identities, and access buildings. They're now part of everyday technology, embedded in how we interact with the world digitally. But the idea that no two fingerprints are the same, how true is that? In 2015, a study led by Dr. Anil Jain at Michigan State University found that while the odds of matching fingerprints between two different people are infinitesimally small, there is no guarantee of absolute uniqueness. Dr. Jain's research has shown that certain rare fingerprint patterns can be similar enough to cause ambiguity in large-scale databases used in biometric systems. The randomness of nature means that while fingerprints are incredibly distinct, the possibility of a repeated pattern can never be completely ruled out. This is a reminder that science doesn't deal in absolutes. The unique combination of genetic influences and the randomness of development means that no two fingerprints have ever been proven to be the same. However, the theoretical chance, however tiny, remains. And with larger populations and more extensive fingerprint databases, researchers acknowledge that in the chaotic fabric of the universe, there's room for unpredictability. The science of fingerprints is still evolving, and studies continue to refine our understanding of their uniqueness. In 2020, a study published in IEE Transactions on Pattern Analysis and Machine Intelligence found that the probability of two identical fingerprints existing was statistically negligible. But even the most advanced algorithms used in biometric recognition are designed with a margin for error, acknowledging that true uniqueness can never be guaranteed with 100% certainty. So the next time you unlock your phone or leave a mark on a window, remember, you're leaving behind something completely yours, something that has never existed before and will never be repeated. Or at least, not yet. While science gives us high confidence, it always leaves room for the unexpected. In a world ruled by probabilities and uncertainties, even something as personal as your fingerprint may not be immune to the randomness of nature.